Okay, so from our 3 experiments, we have discovered 3 things. So, in the first experiment, we changed the length of the wire and kept the material, the cross-sectional area, and as much as possible the temperature the same. And what we found out was that resistance is directly proportional to length, i.e., if we double the length of the wire, the resistance will double. In the next experiment, what we discovered was that if we change the thickness of the wire and keep the length the same, and the material and the temperature, that resistance and the cross-sectional area are inversely proportional, i.e., if we increase the thickness of a wire, the resistance will decrease. And in fact, if we double the area, cross-sectional area, the resistance will halve. And the other thing we found was the material that it's made of matters. There's no way of quantifying that. Well, not that you know of or need to know of, but different materials, even if they have all the same dimensions, wires made from different materials will have different resistances. And what we want to do is really want to explain these 2 things. How come if you increase the length, the resistance increases, but if you increase the thickness, the resistance decreases? And resistance is the opposition to the flow of current, and the current here is the charged particles, the electrons. Okay, so what we're saying is it's harder for electrons to move through a longer wire, but easier for them to move through a thicker wire. And it is all in terms of those collisions. So if we have 2 wires, and this wire is twice as long, you should see if we have a tiny little electron here, or a few tiny little electrons, and they kind of meander their way across. They don't go in straight lines, but they kind of vibrate as they do so. But in this one, we just have 1 collision. Okay, one of our electrons collides in that length. However, if we do the same thing over here, maybe this electron collides again. Wouldn't necessarily have to. This electron makes it through, but then collides over here, and then this electron doesn't collide. Because the length is longer, there's more ions to get past, collisions are more likely. Okay, and in fact, because this wire is twice as long, there's going to be twice as many collisions, therefore the resistance is twice as high, which is why when the length increases, the resistance increases in a proportional manner. However, if we do the same thing here, so let's start off the same way. Let's get, let's have a few electrons making their way through. We'll have this one crashing here. We'll put another wee electron in just because it suits our purposes, and this one makes it through just about. Okay, so you can see we have 2 collisions there. However, if we then have a wire that is twice as thick, those electrons don't need to be as close together. And yes, this wee guy might crash again, but now because these electrons are more spaced out, they are more likely to be able to make their way through without hitting in. So, like I say, quite random paths, but they all flow eventually in one direction in general. So here we have 2 collisions, here we have 1 collision. Give them more space to move through, and there's going to be less collisions, and therefore the resistance decreases. Why do different materials produce different resistances? And it all has to do with how tightly they hold their electrons. If they hold their electrons really, really tightly and there's very few free electrons, then even if you produce a big push, you're not going to get a big current because there's not that many electrons that can move. But if you have a metal that has lots and lots of free electrons, they don't hold on to them that tightly, you have lots of electrons that can flow, and you give them even a small push then, small voltage, you'll get a big current because there's so many free charged particles that are available to move there. Okay, so that's why materials such as glass and plastic have a large resistance, but things like copper and gold have a very small resistance.